let's go to the term of successful well. We have successful well in a short term, and we have successful well. يعني successful well, it's you mean you make like a good achievement, but this good achievement you did it in the short term ولا for the long term. This is what we call short term successful well and long term successful well. The short term, this is maybe common between most of us, يعني maybe not for all the people working for geosteering. This information it's for all the people that work in exploration and production in oil and gas. يعني. If you want to have a successful well in the short term, you should have no accident, no blowout, no stuck pipe, no issues with completion. You run your completion smoothly. The well should be on time. You don't spend too much time. That's why time is money as well, and budget. And you exert like you spend a good budget, not too much. And you get hydrocarbon, you get oil or gas in an expected rate, and you produce oil with no unexpected fluid like water, or maybe some people targeting oil and they don't want gas, or vice versa. The gas is economic and the oil is not economic, or vice versa. The oil is economic and gas is not economic for them. That's why they want to achieve certain kind of fluid, and they don't want to reach or to get the other stuff. This is what we call it successful well for the short term. Let's go into the successful well for the long term. Long term, we mean we have sustained production. Yani you don't have like a production for 10 years, 20 years, and after that you don't have nothing. Your well is depleted. That's why we need, if we plan for a good well, we plan for, good long-term successful well, we should have sustained or extended production. Also delay, one of our colleagues, he mentioned something like this, delay the coming of water or the intrusion of water. This is also one of the important stuff. That's why geosteering will be important in this, because you place your well in a level that help you to delay this onset of water. Reduced issues with intervention later on, workover stuff and intervention in the well, maybe because of wrong trajectory or issues with completion. So you don't want to having an issue later on. And increased ultimate recovery, to get a good and sustained recovery as well. So this is a quick summary about short-term, long-term successful well. Why I'm mentioning this? Because geosteering will help us to help and to get to this type of wells, the long-term well. Okay. What now we will start having some slides about what is the challenges we face during the geosteering. The first challenge we have, one of the first challenges, is the changing the level of your target. Maybe you face your target deeper, or you face your target shallower. This is one of the first thing that you want to look at during the geosteering. That's why good correlation between your previous measurement and your real-time measurement, it will be helpful on this. Also, you may have like a structural uncertainty. You didn't plan for a fault, and you suddenly get a fault during drilling, and this is usually happen. maybe this has happened due to some, if you have like a seismic quality and the seismic quality is not that good, or you have a good seismic quality and you have some kind of sub-seismic fault. يعني الfault it's not like a big enough to be traced on seismic section. That's why you don't expect a fault, and then you start drilling and you face fault during drilling. That's why geosteering guy will take care of this. While placing the well, when he starts see a fault like this, we will see, we'll get the fault from the measurement we have while drilling. Then he will start to react to this fault and get back into, if he exit from the target, he start calculate this fault and calculate the displacement of the fault, and you will start to get back to the main target. This is just uncertainty stuff. We have it commonly in geosteering. This is very common uncertainty. Okay, there is lots of challenges we face during geosteering. Maybe we cannot spend too much time in we have many of the challenges. Sometimes you have, this is your base zone, and you start to have like a bucket of shale like this. So this is very challenging because maybe here you expect that all of coming it will be shale, and suddenly the shale will disappear. So maybe if you take a decision based on this and you get like an up, so that's why this is one of the challenges. A challenges as well is to map a reservoir boundary. Yani to see the top of the reservoir and bottom of the reservoir, and to stay in a distance from the upper boundary or lower boundary. So usually in geosteering we have like a roof or a cap, and we have a bottom. So you have like your roof and you have the floor, and you want to navigate in between. You want to stay between the roof and the floor. You want to stay in between, or in a level, or in a distance from the roof, or in a distance from. We will open we are opening stuff, and we will get more slides about this as well. Okay. Also, maybe you have different zone and you want to stay in a one layer. Maybe you have like multi-target and you want to focus in one target. Also, landing a well with a high depth. Maybe when you have a very dangerous stuff here, and you want to directly or aggressively land your well, this is also one of the challenges. You should get away from this bottom very quick. Also, one of the challenges is staying in a distance from a boundary that we have. Like we have a shale, and this is very common, and you want to you don't want to get into this shale, so you want to stay above. You want to stay above this shale. Or if you have a multiple oil-water contact, like you have different oil-water contact, so this is also not easy, because your oil-water contact is not similar. Is it changing due to structure, due to some stuff? That's why steering also very challenging here. Okay, maybe benching out. The layer will decrease. That's what this is also unconformity stuff. Fault zone. Here you are in the block, and then suddenly you start to be in another block. You have water zone, and you want to be away from the water zone. And sometimes I was in a job that we have like a fracture stuff here. You have like a fracture zone. And you want to stay away from this fracture zone, because the fracture will make like this. And you can imagine that you have fracture, and the fracture will get the water into this stuff. That's why you want to get away from this fracture zone, and hence this water. Or similar to what we have before, the shale stuff. The shale is changing with you. Or maybe you have like gradient of resistivity. You have like gradient of resistivity from, we don't have like a sharp, if we have like a sharp contact between oil, and our petrophysicist here will understand this. If you have like a sharp contact like this, this is مثلا oil and this is the water. So now it's okay. This is your oil-water contact. But if we have a boundary like gradually like this, maybe it's not easy because where is your oil-water contact? This is sometimes is very challenging as well. Okay, this is just example with what we have. What is our tools? I talk too much about tools, measurement. We use it while geosteering, or we use it to achieve a successful geosteering. So this is like the common BHA. BHA is the borehole assembly, or your tool set that you get it downhole. This is for the people that first time hear about this topic. That your set of tools and the bit and the power drive or the motor, that you use it to drill your well and get measurement. This one we call it, this is the bit and this is the power drive, or the steerable system we have. This is what makes the bit go up and down, or left or right. You have like a tool, like a resistivity tool, or maybe resistivity or other tools, but we have this one is common resistivity tool, and we have the MWD. We will explain what is MWD. And we have like a density neutron tool. For petrophysicists, or for people already know about well logging, they know what is density neutron and they know what is resistivity. And MWD is the part of tool responsible for transmission of data from downhole to the surface using some mud telemetry system. We'll go through it in the upcoming slides. Okay, let's have now what is the, if we are talking about geosteering as a process, let's know what is the procedure, what is the steps of geosteering, what is the phases of geosteering to do a successful geosteering, how we start and how we end, what is the methodology for this, what is the procedures for this. Okay, first thing is the well planning. Well planning means you plan your well. And let's go to this one. Okay, just allow me. What do you mean by making a plan? You have something like this. This one we call it plan, or we have like depths. This one we call it inclination. This one we call it azimuth, and this one we call it the TVD. The depths, at which depths that your angle will be how much. We describe the bit orientation in terms of two stuff: the amount of the angle itself, how much the bit is 5, 10, 60, 70, and so on, and the position, the direction, the orientation is directed to which direction. Is it to north? Is it to east? Is it to left? Is it to right? Is it up? Is it down? This is what we call it. So we have inclination, and we have azimuth, and we have our expected TVD. TVD, the true vertical depths, at which depths you will be, how is your bit orientation or your drilling parameters. Okay, so this is what we call the well planning. So you plan your well, you put the plan. Also, while putting the plan, you may focus in some stuff like what we see here. You have this is we call a map, 2D map, and you have different wells. You have well 1, well 2, well 3, and well 4, for example, and you want to drill a new well. So you have to avoid collision with other wells. Either collision in either to يعني if you have like a well like this, and you may enter your well like this in the vertical section, I mean, or you have a well here and your well can touch this well. So this is what we call it anti-collision. That's why we have a job description called a well planner. This guy, well planner, he focus on this. He will see the plan from the other well and how your plan will be safe relative to the other well. It's not a matter of putting a plan and then collide or make an accident with other wells. That's why this is the guy who do this stuff. We call it well planner. Also, define the dog leg. What is dog leg? Dog leg is the function or the aspect that control how much you will build or you drop the angle in the stand in the 100 feet. يعني how much you will build the build or drop rate. I make it simply. So maybe sometimes you cannot build very strong. يعني cannot increase the angle very strong. So you have like a window. The window defined based on the tool you have, how much the capability of the tool you have to build or drop, the type of the motor that you use, and also it's controlled by the geology of the area and also by the later on production, because maybe if we drill with a high rate, or we build with a high rate and we drop with a high rate, maybe you will end up having something like this. This stuff will make issues later on with completion. If you have like a cased hole production, this will make some issues and lots of just we are simplifying. That's why maybe you need to build your well. If you will create your well, you need to create your well maybe smoothly. يعني you make like this, maybe then you drop like this, maybe like this, maybe not like this. This is maybe sometimes you cannot even do it, and if you have like a strong motor to do it, maybe it will affect the production later on. That's why we need to the well planner will define these parameters. Okay, pre-job. So now the first part is to plan your well. Actually, we have in our industry, we have operator, the owner, the client, and we have the service company. So the owner of the well, he want to place his well in this area or between this well. Then we came to the part of pre-job. The pre-job, you prepare before you execute geosteering. You prepare before you execute your geosteering job. You do your homework to achieve a good geosteering. So till here, يعني this one and this one, I still didn't go to the drilling. I still didn't start drilling. I'm just preparing, putting a plan based on your wells, your offset wells, and then here we will start make like correlation between, you see how many wells you have in this area. Do you have nearby wells in this area? You want to you have like well A and well B and well C, and you want to drill a new well, well D. So you see how much wells you have in this area and how much wells have much data or enough data that allow you to correlate your new well with these offset wells. And based on this, you make like a scenario. Maybe you look to your nice seismic, and you see from seismic that you have fault, or you have like big change in depth. So you make like scenario. You expect that these depth scenario, you have to like to make a model for changing the depth. After putting the scenario, define the target, define the location, putting your scenario, correlate your stuff, then you will go into the real-time phase, which is the geosteering phase. The phase now, this is a phase of well creation. Now you create your well. You create your well based on your previous pre-job preparation data, comparing your real-time data with your pre-job data, or with offset wells data, and interact with the geological changes happen in your reservoir or happen with your target. And this is after finishing the job. You prepare like a report or a decision summary. What is the decision that has been executed in this job? How much build, how much drop, how much achievement of the target, net to gross. All this is, we call it post job or final report of the job.